Hi, everyone. So I'm Kathy Tai, and I'm here with Dr. Norbert Gleicher. Thank you so much for coming.
My pleasure.
We're here in the Manhattan Project Lab, and I'm super excited to talk to Norbert Gleicher about his work and experiences in the IVF and reproductive genomics spaces, and also talk about some of the most cutting-edge technologies today and all the hype and controversies around it. So we're super excited to dive in. But before we begin, perhaps Dr. Gleicher, you can start with an introduction about yourself and particularly your experiences in IVF and reproductive medicine.
Okay, thanks again for having me. I am by training an obstetrician gynecologist, MD, and probably one of the last remaining Mohicans from the first generation of IVF practitioners and scientists. And so I have experience and a lot of scientific involvement over more than 40 years in the IVF field. I've been interested in, especially the last 20 years or so, in the aging ovary primarily. And that also relates to the center that I'm heading up in New York, Center for Human Reproduction, which is pretty well known all around the globe for special expertise with older women or younger women with older ovaries, whichever way you want to call it. And it is really from that experience, dealing with so many older women who usually do not produce a lot of eggs and embryos, that I very early got interested in the concept of fixing bad embryos, because if you're dealing in your IVF clinic only with 25-year-old or 30 or 35-year-old patients, they have all the embryos they need usually. But once you get over 40, it becomes a very sparse product, and every embryo is worth gold. And nothing is really more distressing than not being able to use an embryo that you have created because, for example, a single gene disease. And so I started thinking quite a while ago about what can we do. We did all kinds of experiments 20 years ago, but it now is practically becoming possible, and that's what you are trying to do. And so when I heard about your efforts, I got interested, and that's why I'm here.
Thank you. And I really appreciate you being a scientific contributor to the team. We're all very, very motivated to work on this mission together. And I think getting support from people who are pioneers like yourself really matters and makes a big difference in our progress and speed to execution. One thing that really fascinated me with our last conversation was specifically about the history of IVF in the United States. And the reason why I bring it up is because, as you know, with this technology, it has gotten a lot of attention in the media. And I, for one, have experienced it firsthand, even in 2025, when I feel like a lot of these topics have been covered for many decades. People still love to talk about it in very extreme ways. And so I noticed that even in the previous instance where IVF was invented and created and especially adopted in the United States, there was a similar type of, call it fear or skepticism. Can you tell us about kind of your experience and how you witnessed the IVF industry grow here in the United States?
Okay, I will age myself. I was a young resident at Mount Sinai. I think I was probably my second or third year of residency. Had already my lab, and a crazy story broke. And it broke on the other side of Manhattan at Columbia University, where a pretty well-known scientist apparently tried IVF. And this was a few years before the first official IVF baby really came to be. And this scientist had gotten together with a couple who badly wanted a child, well-off couple, and they offered to finance an IVF attempt. And the woman had an egg retrieved through laparoscopy in one place that was carried by hand over to Colombia, where the husband supposedly produced his sperm. And this scientist, by the name of Dr. Schettler, tried to create a human embryo. And the chairman of the OBGYN department at that time was a very well-known fertility specialist. And he somehow learned about the experiment. And he himself stormed down into the laboratory and destroyed the experiment.
Wow.
And I think that tells it all about what this was, as I said, a handful of years maybe before the first IVF baby was born. Probably the time when Edwards already experimented with it in the UK, and where there was obviously talk in the community about it. But the chief of the department himself destroyed it. And when he was later interviewed, why would you do something like this as a scientist, as a well-known scientist, as a fertility specialist? He said, because we were afraid that he would create monsters.
Wow.
So that was the theme in those early days. And when the first IVF baby was born, that were also many of the headlines in those days in some of the most prominent newspapers, including here in New York City. So we are used to it. Yeah.
That is a crazy story, considering that IVF is so normalized nowadays. You know, many couples go through IVF and without even thinking that it could be controversial in today's age. So the fact that the head of a department would destroy the equipment and the experiment at that time is insane. And it seems like it's been a pattern, though, where a lot of the cutting-edge reproductive technologies, when it's first developed, has this extreme reaction from certain members of the scientific community. And I can definitely see that with the technology that we're working on today. And just for context, Manhattan Project, this company that we're at the lab of, with this logo, that's Manhattan Project, we are working on preventing diseases pre-birth with the technology of germline gene correction. And it's really about eliminating disease at the embryo level before they're born, so that people with incurable diseases have a chance to grow up without these diseases. And with this technology itself, over the last decade, there's been a lot of media scrutiny. I definitely think that there's a very good reason to be cautious with this technology. However, it seems like there is kind of a pattern here with reproductive medicine as a whole. And what would you say? You agree with that?
Yes and no. I obviously, as this example shows, and I can give you many other examples, even in following years, where the field and the newspapers and therefore society to a degree overreacted. I mean, I myself was hit 20 years ago, or a little longer than that, with one of our studies, which was completely misunderstood and falsely projected in the media, etc. But at the other side of the extreme, we also have to acknowledge that not everything that has been done or is done is necessarily appropriate or supported by everybody and or agreed to by everybody. And the concept of testing embryos and changing their genetic makeup can be controversial if you misuse it. You know, if you have a single gene disease and you eliminate the genetic defect and And an embryo that otherwise would create the baby that dies 24 hours after birth, if you prevent that, who can argue with that? If you want to do the same thing, to have a baby with blue eyes, it's already a different story. And I think that's where we all have to be careful and know what we are doing.
Absolutely. I think there's a very important line to be drawn between disease prevention and enhancements. So that's definitely good that we're talking about that now. And also speaking of, possible controversial technologies in this space, one thing that you have been quite vocal about is around the new technology of PGT-A in the embryo selection process. Do you want to talk a little bit about that and your thoughts?
Yeah. So embryo selection, for those who do not know very much about IVF, means that in most IVF cycles, especially in younger women, we usually get within one cycle quite a good number of eggs and therefore embryos. And then always the question arises, which embryo do we use? Which embryos do we store away, freeze? Or which embryos do we dispose of because we think they are not going to do anything? And that process is called embryo selection. And the idea that there must be a best embryo amongst every cohort of an IVF cycle was created in the very early days of IVF, so 40 years ago plus. And frankly speaking, the older I've gotten, the less I have believed that this is really a very valuable hypothesis. Because frankly speaking, at least in most IVF cycles, I think the differences between embryos that exceed what is obvious by looking at them to every embryologist is probably not big enough to make it worthwhile to invest the time, the money, and everything else. But it is the single topic that has consumed most research time and most research money in all of IVF. And it is still being pursued left and right. And when you open our medical journals, it's always a topic. Everybody's inventing a new way to find the best embryo, and nobody has ever succeeded. And the most expensive and, in my opinion, most harmful way to select best embryo was actually born in Chicago in the late 1990s. And it was the brainchild of a good friend and colleague and competitor of mine by the name of Yuri Verlinsky, a brilliant guy, who concluded that because when you look at miscarriages, at least half of them are chromosomally abnormal, he concluded if we test embryos before we put them in an IVF cycle, we will prevent all of those miscarriages from happening, and therefore we will select better embryos and have better pregnancy rates. And when I first heard the idea, I was so fascinated. I was a young department chairman at that point at one of the academic hospitals in Chicago. I went out and hired a geneticist to start a laboratory to do this kind of testing. Cut a long story short, within a year or two, because of work that some Belgian colleagues did and published, I became very skeptical about it. And actually, with a colleague together, we reanalyzed the data, and we concluded that the data actually not only suggested that this kind of testing didn't really improve outcomes with IVF, but in older women may actually be harmful. And we tried to publish it. And we couldn't publish the paper.
What?
Nobody wanted to accept it because everybody believed so strongly in the concept of testing embryos. We literally submitted it to every reasonable journal, both in the infertility field in general medical journals, we couldn't. For 2 years, the paper went unaccepted until some colleagues from the Netherlands published an original prospective study where they showed exactly what we had concluded from reanalyzing the Belgian data that the Belgian colleagues had done. And New England Journal of Medicine accepted the paper, obviously very highly prominent journal. And then the editor-in-chief of Fertility and Sterility, which is the leading fertility journal in the US, he called me up and said, "Didn't you send me a paper a year ago that said kind of the same thing?" I said, "Yes, and you rejected it." So he said, "Send it again." So I sent it in and it was finally published, but only after the Dutch group published their paper. Right. So, in other words, from that point on, I have been very skeptical about the concept of PGT-F testing embryos. And I must say, I have been proven right. Last year, finally, our big professional society came out with a formal policy statement. After over 20 years of using this test, where the ASRM said that it doesn't do anything. And so the question that the ASRM did not address, and that is a pity in my opinion, is if something hasn't worked in 20 years and hasn't done any good in 20 years, why are we doing it? And we are still doing it. So over half of all IVF cycles in the US currently use it.
Wow. Well, with PGTA, also one thing I learned is that, with the biopsy process also could damage the embryo in that process. And I've also heard that a lot of chromosomal abnormality can be fixed naturally in the embryo.
Absolutely. We showed that in humans. British colleagues first showed it in mice, and a few years back, in collaboration with Ali Brivanlu's lab at Rockefeller, we showed it in humans. Absolutely correctly. And actually, just this week, I just got it today, a paper came out again from British colleagues that confirmed visually they were able to catch on camera how aneuploidies happen in the preimplantation stage embryos sporadically all over, which then can again disappear.
So what you're implying is that some embryos were discarded, even though they could have been healthy because of this process.
Not only some, millions.
Millions of
in my judgment, millions. Yes.
Wow.
Yes. Huge numbers of good embryos. And actually, once again, we were the first ones in the world. It's now also already 10 years ago to start transferring so-called abnormal embryos, chromosomally abnormal embryos, selectively, obviously not everyone. We concentrated on those alleged abnormalities where it was known they wouldn't survive, they would miscarry or be lost. And we were the first ones to report 4 healthy pregnancies following transfer of allegedly abnormal embryos that everybody else was throwing out. And so in the meanwhile is that, again, come back to ASRM opinion of last September, it's widely accepted that embryos can also self-correct. And it is obvious, for over 20 years, we have discarded huge numbers of good embryos. Yes. And with it, obviously, significant pregnancy chances.
Well, that is a shame and definitely saddens me to hear. Now, shifting the focus a little bit into 2025, now there are many companies that advertise the service, especially those that have been funded and have quite a bit of a media presence. I think even regular people have heard of these companies that do things like embryo selection on select traits. And with the history of PGTA, especially over the last 2 decades, Do you foresee any issues with the current industry of PGT as a whole?
Yeah, that's a very, very important and again controversial question issue. You're absolutely right. It's pretty much the same people who have been pushing PGTA as a routine test. There are IVF clinics who will not take you into an IVF cycle unless you agree to do PGTA. Okay, that's how far it has come. But it is some of those same people, those same laboratories that have been and still are pushing PGTA, who have started to offer what now is called polygenic risk screening of embryos. And that is a term that really comes from adult medicine, where over the last decade or so, through our improved genomic understanding and through new technology, AI technology to a large degree, it has become possible to predict risk for not single gene diseases, but the vast majority of diseases, which are so-called polygenic diseases. That means they're depending on many genes. Single gene diseases are easy to predict. There's either a 50% chance of passing it on. If it's a dominant gene, a 25% chance. If it's a recessive gene, 50%. If it's a sex-linked gene. So we know that for so-called single gene diseases like Tay-Sachs or sickle cell disease. So those are single gene diseases. But if you want to know what is your risk for a heart attack or for a stroke or for diabetes, it works very different because so many different genes are involved. And in adult medicine, through our understanding of genomics and knowing genes and through AI, we now can predict in individuals with reasonable certainty what their risk is to develop heart disease within 10 years or 20 years or develop diabetes, etc. But even in adults, this is not at a point where it can be routinely used in medicine. It's still considered experimental, even in adults. Now, imagine the same concept in embryos. Now, in adult medicine, we can follow patients 10 or 20 years and see how good or how bad are our predictions. But how do you follow an embryo? And even then, we know, again, from adult medicine, that while our genes are of crucial importance in predicting disease, they're only a relatively small part of the story. The biggest contribution comes then from the environment. The genes are the basis, but it is then the environment through our lifetime that influences how those genes work. I always compare that when I explain it to patients. Our genes work like thermostats. Can be turned on all the way, can be turned off all the way, can be somewhere in the middle. And the environment controls that. And apropos, the most important period for our genes are the 9 months that we spend in our mom's womb. That's a very crucial period for establishing or setting the thermostats on those various genes. And so if you have polygenic diseases in risk scoring, maybe all of those risk genes may be responsible, if it's a lot, for 15% of risk. 85% comes from the environment. Now tell me, if somebody is working in a gas station, you know his environment already. But how will you know what the environment of that embryo is that you are testing? And so this whole concept of, okay, now we are back to selecting embryos. I am taking this embryo because it has a lower chance of getting a heart attack, maybe a higher chance of getting diabetes. I take rather this than this other embryo next to it that looks the same way but has a higher chance of developing God knows what other diseases. But all of those to such a little percentage doesn't make much sense, in my opinion. And therefore, the companies that concentrate on that are not only, I think, misleading in what they claim towards the public, but more importantly, I don't think in the long run they will be economically successful because it simply doesn't make sense.
Yeah, I think I already know your answer to this question, but I do have to ask because it is something that is talked about everywhere. A lot of these PGT embryo screening, embryo selection companies advertise that they can select for traits like IQ,
Yeah.
longevity, and possibly other ones. What are your thoughts on those claims?
Well, again, it comes down to if you can then also tell me what the environment of that embryo that you're testing will be in the mother's womb, who the mother is, in other words. And if you can tell me where this embryo will grow up, to which school he or she will go, what she will eat and drink over a lifetime, maybe. But I think nobody can do that. And so what they will predict is, as I said, at best 15% or so.
Mm. Yeah, I think what surprises me about the moral standard or the ethics frameworks today in 2025 in this space is that PGT embryo selection has been mostly accepted, I would say, in a lot of clinics by a lot of people. But it seems like germline gene correction is still quite sensitive.
Isn't it interesting?
Yeah.
They are ready to throw out thousands of embryos or hundreds of thousands of embryos, but they're worried about fixing something that is really broken.
Exactly.
Yeah, it is bizarre, but you're absolutely right. That's exactly what has happened.
Yeah, and it's shocking because, what we're trying to do, and researchers in this space of germline gene correction, what they're trying to do is actually help correct the mutations that are pathogenic in those embryos that would otherwise be in this process.
And are clearly defined. It's not that these are 4 genes or 15 genes or so. It's usually one gene.
Right, very specific
Gene
and mutation.
Yes. It is a relatively easy task, and it's accurate. Yeah. So it's you're absolutely correct. Yes.
Yeah, it just seems like from an ethics standpoint, if embryo selection is allowed and sometimes praised as a positive technology, I think absolutely germline gene correction should be morally accepted, not more superior to as an option to patients.
Absolutely, and I would add to that one other thing. We just had recently a remarkable report in the medical literature where a child who had such a genetic disease, which usually leads to death within months after birth, was treated with genetic methodologies that could be used in embryos after it was the child was already born, which is much more difficult than treating the embryo at the beginning. And this child, at least clinically, was cured, at least for the time being. Nobody knows yet how long it will last and so forth. But that was allowed by the FDA. And so I really cannot see how they would not or should not allow, obviously, properly controlled trials with donated embryos. I cannot imagine that that will not happen within a reasonable time.
Yeah, absolutely. And what one of the things we're working on is to show the safety and efficacy of these technologies because regulators need that kind of data to pass regulations and bills that would allow this technology to exist in clinics. As a clinician yourself, when you see patients and especially those that have genetic diseases or those that would potentially use this technology, do you think they would be open to something like this?
Oh yeah, yeah. I know they will be open.
This is a question that I think about a lot, and I wonder if you have any thoughts on it, which is how should a regulator weigh these different opinions between the general public, ethicists, and the scientific community?
That's again a very difficult but important question. Regulators are either politicians or they're dependent on politicians. And so in the end, it's, in my opinion, always going to be a political question. And it will depend on who is in the White House and who holds the majority elsewhere. Yeah. A lot of people have been talking about the politicization of the various health agencies over the last few years. I think that it has gotten worse, but if anybody believes that politicization didn't exist 20 or 25 or 30 years ago, again, we're back to our initial question about how IVF started. It obviously existed already then. So I think in the end, it will have to be confronted at a political level. And I give you a very good example, not even in the US. In the UK, there was a strong drive to allow embryo manipulation for mitochondrial diseases. I will not go into the detail what that means, but it's a very similar process we're talking here about in general. And the responsibility to supervise the process, which was allowed in only one university, was given to a local authority, which is semi-governmental and semi-private, which controls all of IVF in the UK. But the process had to be approved by the lower house and the House of Lords. So for one clinic, I think 10 cases, it had to go all the way up. And I think, while it may not be as rigid here, but I think the general principle will probably also apply here.
Yeah, that makes sense. I think the US is always kind of looking at what other countries are doing and then making regulations based on that observation. Speaking of other countries, where do you think are kind of the leading countries that are leading this kind of reproductive genomic spaces right now?
That is very difficult to know because I'm very convinced that there's a lot of underground work going on in certain parts of the world. But if you ask me who has the most impressive embryology research in general going on, I would probably have to put Japan at the very top, which has always been amazing to me because their clinical IVF is not very good. They have pretty lousy rates there. But when it comes to the basic science of embryology and understanding embryology, and the big goal in the field is now the ability to create fresh eggs and fresh sperm from stem cells, I think nobody's as far as the Japanese.
Well, that makes sense. And just out of curiosity, I just had to ask, what makes you think that, this technology is being worked on in an underground areas or like parts of the world?
Because the kind of marginal stuff that we're talking about, which we all know sometimes will happen, but is not yet officially allowed, that has always been happening. I mean, the Colombia story is a good example here. IVF in the UK, Edwards did it really underground. They were very quiet about it. China had a case that a few years ago where stuff was happening underground. In Europe, certain countries, Ukraine, for example, did a lot of things until the war broke out and things got interrupted. So we know a few places where stuff is going on. Obviously not the detail, but it usually exists.
It's fascinating. I mean, one thing that we're very keen on here at Manhattan Project is we want to do it according to all of the laws, state laws, federal laws, IRB protocols, ethics committee approvals.
Yeah.
I think that's quite important to push this field forward.
Yeah.
Kind of in the lights, transparency really matters here.
Absolutely.
Otherwise, I think although people can do that, it becomes when it gets exposed, it does set the field back quite a bit.
Yeah. But we used to say in the old days that the best thing that happened to IVF in the US was that it first happened in the UK. Because if we had to go through all the permits, and so I'm not sure we would have succeeded.
Yeah. Okay. I want to suggest a story for you to share, but also linking that to advice that you would give us in 2025 in Manhattan Project and what we're trying to accomplish. But first, a story that you told me last time was super fascinating. I thought about it for a long time afterwards, which is in a year around 2000. There was work that you've done to replace cells at embryos. Talk about that story, or just talk about the advice you would give us in 2025 based on.
I'd be happy to talk a little bit about the story. I kind of referred to it before when I said that I had personal experience with negative public opinion. So I mentioned already before that I have had a long-standing interest in treating older women with infertility, and that these women, usually one of the big problem is that they produce less and less eggs and less embryos as they get older, when they need more and more, because the chance per embryo declines, and therefore the way we can compensate, the only way so far we can compensate, is by putting 2 or 3 embryos into the uterus rather than 1, and thereby get them to a decent pregnancy chance. So I have had a long-standing interest in older infertility patients, and I was then still in Chicago, running an OBGYN department, and I saw in the literature a paper about a child with a genetic disease. I don't remember which one. And the paper was about the fact that the symptoms of that child could be eliminated completely if the treatment that was given just reached roughly, I don't remember the exact number, 15 or 20% of cells. In other words, in order to cure the child, you didn't have to get the drug into every single cell, even though the gene for the disease was obviously in every cell in the body. And that gave me an idea. And the idea was, okay, if not all cells are needed for cure, why not try to put healthy cells into embryos that were diagnosed as diseased? And the next obvious question, or the first question then was, would it work? Would it work taking from a healthy embryo 2 cells and putting them into a 6-cell embryo and thereby replace a third? And would those be integrated into that embryo? And in other words, this embryo, if it ever became a pregnancy and a baby, would have a third of its cells not affected by the genetic disease. Kind of the same idea we have now, but much more primitive technically. So how do you test this? In those days, we didn't have, I'm talking over 20 years ago, we didn't have all the modern day single cell analysis, etc. Things were much more primitive. And so we decided to use some of the embryos we got donated for research purposes. We determined which ones were female and which ones were male. And you could mark them with fluorescence dye very easily, very simple experiment. And then we took a day 3, 6 to 8 cell embryo male, removed 2-3 cells, put sibling cells in that were female, and followed to day 5 and saw, are they being integrated? And we saw they got normally integrated and they influenced the embryo. So we submitted an abstract to the ESHRE meeting. That's the biggest fertility meeting in Europe every year. And we were selected as one of the 3 or 4 finalists for the big award. And before the award was to be announced, there was a press conference. And at the press conference, all the finalists gave a very short presentation of their paper. I did it. And then I went with a colleague to the beach. And about 2 hours later, my phone started ringing like crazy. To cut the long story short, one of the reporters made a huge stink out of this. What we were doing was unethical and created monsters and God knows what. Our abstract did not only not get the award, but was withdrawn. We were not allowed to present it. My daughter called me, my little daughter then called me up, Daddy, what did you do? Because she saw it on television. And and we obviously stopped this research. We felt it wasn't worth it. But I must say, the journal I mentioned before, Fertility and Sterility, that did not accept our initial PGTA paper. They did accept that paper for publication, and it was published. Yeah,
That's incredible. What a story. I mean, that was if you want to call it, the original germline gene therapy.
Could have been.
Yeah.
It is interesting. I mentioned that we have a very close collaboration with the Brivandl Laboratory at Rockefeller University on several issues. And they have done in animals this kind of chimera experiments, and it is really amazing how well things get integrated at those stages. It's really amazing.
Yeah, wow. And yeah, there goes that media pattern. I think somehow it always goes back to Frankenstein. No matter
Yes, monsters and Frankenstein, those are the 2 terms, yes.
Or Frankenstein's monsters. That's very interesting. And given that you've had that experience, all those couple of decades ago, I think we're still seeing some of the challenges in media and portrayal of certain science like germline gene correction today. What would be your advice to us at Manhattan Project when dealing with this type of pressure or kind of these different limitations and things that will be portrayed a certain way in media?
Transparency, cure rather than enhancement, and transparency again. I think that's the only way to do it. People need to be convinced that they know what you're doing, and there's no reason why they shouldn't know, because nothing that I think you would support or I would support would, at least in my opinion, come even close to being unethical.
Yeah.
Yeah.
Yeah, I think it's about doing it the right way. I mean, there are many shortcuts that, I've seen people talk about, whether it's going to do this underground or in a different country. And I think there's definitely a lot of merit to doing it the right way in the United States. So that's definitely something we'll keep in mind as we continue to grow.
Yeah, I totally agree. Yeah.
Okay, yeah, that sounds good. Thank you so much. I really appreciate that. And also for you to come here today and speak. I know you're super busy between traveling and conferences.
My pleasure. Always love to talk about these subjects.
Awesome. Well, thank you so much. And
My pleasure.
thank you all for listening.